still absorb.
All right, so I think the only thing that we can do here maybe is try to do this by contradiction. So let's assume that it has 4 roots. Okay?
Well, can you assume that
So,
it has 3 or 2?
if it has 4 roots, then how many times will it cross the x-axis? And that means it will cross the x-axis 4 times. Okay. And so if it's going to cross the x-axis 1, 2, 3, 4 times, according to Rolle's theorem, how many places must there be where the derivative is equal to 0? 3. So if it's going to cross the x-axis 4 times, then that means there will be 3 places where the derivative equals 0. Okay? But this leads us to a contradiction, because the derivative of a polynomial of degree 3 is a polynomial of degree what? 2, which we know is a parabola, which we know will cross what will be equal to 0 how many times? Only twice. Okay? Therefore, it can't have 4 roots, so it has to have 3. Okay? That's a little bit, sketchy, but that's the basic idea. Same thing with show that a polynomial of degree n has at most n roots. If it had n plus 1 roots, that means it would have to cross n plus 1 times, which means that it would have n places where the derivative equals 0. But if you take the derivative of a polynomial of degree n, you get a polynomial of degree n minus 1, which will only equal 0, n minus 1 times, not n times, so it will not equal.
You're just ready.
Okay? Oh, for sure. Yeah, but I'm not like, Well, Miss Eckerson, you guys in a minute, but I'm going to work with the kids that actually are doing their work and trying. I'm not going to teach. I'm not going to teach to the lowest denominator in the class. I'm going to teach to the highest.
Let's teach the average.
I'll come and get you in a minute. Stay where you are. I'll be right back. Okay. All right. 28. Suppose f is an odd function. All right. Now let's stop right there. What does it mean for f to be an odd
It's flipped
function?
over to x.
Okay, no,
Yes, it is, though.
No.
The x is negative.
no.
It says right there. Negative b.
What does it mean if you have an odd function? That means that if you take a number x and you plug it into the function, and then you take the number negative x and you plug it into the function, what will you get? Negative f of x. Okay? Same answer, but opposite. So if you plug in 3, then you get 4. But this says if you plug in negative 3, you'll get negative 4. Okay? Whereas an even function, if you plug in f, you get f of x. And then if you plug in negative x, you still get f of x. Okay? You get the same answer both times. So odd function means this is what's happened. All right? Also, if it's odd, what is the symmetry? Taylor tried to say x-axis, but it's not. The y-axis is if you're even. Flipped over the origin.
Origin.
Yeah, it's symmetric with respect to the origin. So, for example, if you have a cubic, which is an odd function, then it looks like something like that.
Can you
Okay?
watch that over the origin, please?
All right. Prove that for. I already did.
When?
I did. I took this piece right here and flipped it over the origin, and I got this piece right here. So you're done.
How does that work?
Because if I take this point right here, and I go right to the origin, and then I come out the same distance, then I'm
Oh my
done.
gosh.
Okay? Yeah, flip
That's
it
scary.
and then flip it. All right, prove that for every positive number b, there exists a number c in between negative b and b. So let's say this is b and this is negative b, okay? So this is going to be, and I might have to redraw this graph, this is going to be our region, okay? such that the derivative of C is equal to f of b divided by b?
There's a guy no answer, but it's pretty cool that it's.
What the heck does that even mean?
Skip it. You know,
What? Hold on, just calm down. What would you? Huh? That is weird.
Pay attention.
All right, so here's what's going on. It says f satisfies the conditions for the mean value theorem because you know it's a polynomial, right? So it's differentiable and it's continuous. So we use this theorem on the interval negative b to b. So according to the mean value theorem, if these are my 2 points, and let's just pretend that this is f of b right there, since I have that labeled already, and this is f of negative b right here, what the mean value theorem says is that somewhere in between those 2 points, there will be a tangent line that has the same slope as that secant line, right?
Will you say that
Okay.
again?
Yeah, what the mean value theorem says is that somewhere in between these 2 points, there's a tangent line to the curve that has the same,
Got it.
okay? All right, and so in other words, if we write that out mathematically, the slope of this tangent line would be f of b minus f of negative b divided by b minus negative b, okay?
Oh, wait, this is.
I think I get it.
This is what we did before.
I got it, okay? That's all I needed. Are you ready for this?
No, hold on. You have to wait. So this is what we wrote down yesterday,
Right. Okay, according to the little discussion that we had at the very beginning, what would f of negative b equal? It would be negative f of b, right? So this would turn, because it's an odd function, so this would turn into being f of b minus negative f of b, right? Because f of negative b is negative f of b, okay? And then b minus negative b is 2b, right?
Or not.
And then the negatives cancel and make positives, so this would be 2f of b divided by 2b, the 2's cancel, and we have what we wanted to,
Hold on.
okay? All right, so since the mean value theorem says that somewhere in there a point exists such that this is true, and then we can do the fact that it's an odd function and simplify that to be f of b over b,
That's gonna
then we
equal.
know, yeah, that's what we wanted it to be. All right, now, so that's a little bit tricky. That's interesting. All right, what's the next one?
29.
29. All right, use the mean value theorem. What is all these proofs? Who gave us all these proofs? Use the mean value theorem to prove the inequality that the absolute value of the sine of a minus b is less than or equal to a minus b. All right, ready? We're going to just go right to the notes here. Okay, so let's let f of x equal sine of x. Okay? And then let's, for some reason, decide that b is less than a. Okay? Hey, come on, Gabby. What are you doing? I'm trying to teach you calculus,
I didn't do any of it.
which is all the more reason to pay attention.
That's why I moved, because they were so distracted.
You're not cheating. You're not cheating. Think of it as being done. Okay? All right, so if this is all true, by the mean value theorem, there's a number in between a and b, right? So that wow.
What is the equation for real life?
Oh, Mary, don't you dare go there right now. By the mean value theorem, we know that f of b minus f of a over b minus, oh wait, I have that backwards because b is less than a in this case, huh? So this is really,
F of A minus.
yeah, sorry. So this is, for some reason they went backwards, f of a minus f of b over a minus B. Okay, so we know that there's a number in between A and B somewhere where the slope equals that, right? Okay, so this would be equal to f prime of C. Okay. So now what? Now let's multiply randomly both sides by A minus B. So let's rewrite this as f prime of C times A minus B equals f of A minus f of B. Oh my. Okay, what is the derivative, since we let f of x equal sine, what's the derivative of sine? Cosine. So f prime of C is going to become cosine of C times A minus B equals f of A minus f of, whoops, minus f of B, okay?
What happened to the?
Yeah, nope, don't have this one, not happening. Sorry that I signed that.
It's all right.
Not sure where they're going with
That's
that.
not obvious.
They do something in here with cosine always being in between -1 and 1. Yeah, I'm not happy about that either, okay? I don't know. All right, are we done yet, Jefferson?
34.
And then that's it?
Yeah.
Okay.
We didn't even have 34.
Good enough to do that?
No.
Nope, didn't have to do 34. Okay, are we good? We're good? Okay, anybody else need help with anything? Anybody else need help with anything?
Not yet.
No? So you just need to work?
Yeah.
Not
Could have been doing while I was going through those problems?
I mean, I could have, but I have my priorities.
Okay. Yeah, you do have your